So yes, friends, Nirma Oza here once again. We have started distance protection of transmission lines. We have taken one class of that distance protection, the first class, just to initiate the discussion on distance protection and to clear certain fundamentals of distance protection. So in this same class, we'll go ahead and we will see the different characteristics that those are used in distance protection. For protection of transmission lines, what kind of characteristics we are using, that we would like to see in today's class. The characteristics that can be used are impedance, ohm, reactance, and more. They are the four standard characteristics usually used. Or I should rightly say the word usually were used. Now the use is becoming less, right? Because modern characteristics are coming. Modern rather technology is coming, and that modernization is changing the era, is changing the kinds of characteristics. But these four characteristics will take first, because you see, we would want to understand the distance protection first. These characteristics can well be realized by electromagnetic and static constructions. So they have been used since 1800 and something, I don't know. More complicated characteristics which cannot be realized by these relays, and we have to use the numerical relays. We will not discuss much, but we will discuss them, or we will touch them while we would be talking about the problems of distance measurement. Because we say that the distance relay measures the distance from relaying point to fault point, but it is not really doing so. It is creating many problems while doing so, and many of the problems can be solved by the use of the modern numerical relays. So those we will be seeing while we will be discussing the problems on distance protection. But now we will see these four basic characteristics. And my friends, as the topic is long, today we will be able to discuss only 2 out of 4. And in the last protection of distance, I mean last class, I mean the 4th class of distance protection will be, I'm sorry, this is the second class of distance protection. So in 3rd class of distance protection, we'll be discussing the other 2 characteristics. Yes, so the first characteristic is impedance relay. We have already discussed about it. Amplitude comparator impedance relay is already discussed. It is a circle, and it has an origin O. relay lies at O, and at the periphery is the impedance. Impedance under threshold condition, right? If the impedance falls anywhere under uh, the circle, the relay operates. If the point falls, impedance measured by the relay falls out of the circle, the relay blocks, right? But we were also telling that the manufacturers usually do not prefer the phase comparators. They go for, manufacturers do not prefer amplitude comparators, because amplitude means it is the amplitude of current you are using. And amplitude of current, when the fault occurs, is large. Therefore, the coil size will be larger and the relay will be larger size-wise and costly cost-wise. So rather than that phase comparator, you can attenuate the quantities and just compare the angle between two quantities. And if the angle between two quantities is 90 degree, it is threshold. Less than 90 degree, it is operate, and more than 90 degrees block. And this can be proved mathematically, no doubt, but I have not proved it mathematically. In Van C. Warrington, the Bhishma Pitamaha of power system protection, uh, I don't know the year in which he had written book, 1900 and something, or no. But the book, he has dedicated the book to his wife, and many people do that. It is not very unusual, but the line he has written below it is very important. Dedicated to my wife, who gracefully accepted 18 months of grass widowhood. I'm sorry, those who are not understanding Gujarati will not understand, but we in Gujarati call it Chate Patiye Vaidhavya Vethu. The husband was live. Who is called widow? Widow is the person whose wife is not there. Wife was there. Wife was not dead. But he did not see his wife's mouth. He did not meet his wife for 1.5 years. So you can see what kind of book he had written, and you can compare the PhD thesis is being prepared by hundreds and lakhs of PhD thesis is prepared by the teachers. You see, you can read that book and you will come to know that what kind of thesis it is, what kind of book it is. In that he has mathematically proved also that how some quantities would render impedance, some quantities would render reactance, some quantities would render uh, Ohm characteristic, etc. Uh, Mathematics is there, and mathematics is always little. Uh, it is an imaginatory subject, and I say that the mathematics is comes from the. Uh, it is just. It cannot be learnt. That means there is no method to learn it. You feel, you get an idea. Some people were telling that in earlier days, Rishi Munis were teaching about the trees, and before that, teach about the gulab tree, rose tree. They would sit near the rose tree for one day fully, day and night. Understand who are you, and then they would teach on the next day. So it's more a question of understanding somebody, understanding something, and then teaching it, not teaching from by reading from book. just by teaching from reading book from book is not the thing. So mathematics is not a subject of I mean you cannot teach it, you cannot learn it. You have to feel mathematics. So I'm leaving aside mathematics, but geographically it can be very easily proved. Sorry, not geography. Geometrically, using geometry, this can be easily proved that by phase comparator impedance relay, you can measure impedance. So how you can measure impedance using the phase comparator relay? So let us see that. So I've got two quantities Ki and V. We have talked about it. That Ki is coming from the current coil CT, because across CT I have connected impedance K, which is a replica impedance of the line which I want to protect. And V is the measured voltage by PT. That means voltage from relaying point to fault point. I am comparing these two vectors because both these are vectors. Current is a vector, voltage is a vector. So you can see that Ki and V. Ki is, V is lying on the circle. That means this is a threshold condition with reference to amplitude temperature. I know that it is threshold condition. So what I have to do for phase comparator, I have not to feed Ki and V, but I have to feed sum and subtraction of Ki and V. That means Ki plus V and Ki minus V. You can see, you can very well see. I have added Ki and V, vectorially obviously, and subtracted Ki and V because minus V is this side. Therefore, Ki minus V. The angle between Ki plus V and Ki minus V is 90 degree. And it can be geometrically proved. There is nothing, it is not very difficult to prove. You have to simply complete this rhombus. This makes a rhombus. That means if you extend this to same length, then parallel line to this, and then extend this also to same length this side, it will be a rhombus, and the diagonal of rhombus bisect exactly at 90 degree. Therefore, alpha is 90 degree. That can be proved. So phase comparator impedance relay means the quantity that you feed, both the quantities are at 90 degree. Then the relay is under threshold condition. Relay will neither operate nor it will not operate. If you want to see operate condition, then we should be inside the circle. So with reference to amplitude comparison, you know that Ki is less than Ki is more than V is less than Ki. Therefore, relay should operate. Ki plus V and Ki minus V I have done. The angle between Ki plus V and Ki minus V alpha is shown, which is obviously less than 90 degree, and therefore relay operates. It was operating in amplitude comparison. It's operating here also, right? So this is the operating conditions for phase comparator impedance relay. Then another kind of characteristic is reactance relay, not impedance. Reactance relay is a characteristic. A reactance relay is a relay which measures the reactance of the line to be protected. It does not see resistance at all. It measures only reactance of the line to be protected. And if that measured reactance is less than the set reactance K, then relay operates. If the measured reactance is more than K, the relay blocks. You can see K is the set reactance. Reactance only of line. Transmission line to be protected is shown. If the fault is below the reactance characteristic, then reactance measured will be obviously less than K, otherwise more than K. Very clear cut, no? So, any area, any point which lies above the reactance characteristic obviously horizontal to R axis, resistance axis. And any point below the reactance characteristic gives you the tripping point. Right? That is a reactance characteristic. So, reactance characteristic. Now, where this reactance characteristic would be applied, where reactance is good and where impedance is good, which is good at which point, that we will see later when we discuss the problems, etc. Right? Not now, but let us understand that so many types of characteristics are available. If you convert this into phase comparator and amplitude comparator, then phase comparator reactance relay compares Ki minus V and Ki. If angle between Ki minus V and Ki is less than 90 degree, relay operates. Equal to 90 degree, threshold. More than 90 degree, block. As an amplitude comparator, 2Ki minus V and V. V is the restraining quantity. 2Ki minus V is operating quantity. If 2Ki minus V is more than V, operate. Equal to V, threshold. Less than V, block. Simple, no? I mean, not very difficult. So, amplitude comparator and phase comparator. This is just a table to show you what we have done. 2Ki minus V and V. Characteristic angle is 90 degree. That line Ki which you have drawn, right? The line Ki that we have drawn, K is at an angle of 90 degree to R axis. लगाओ तो भरती भरती હમણાં બોલશો નહીં ચાલુ છે ચાલુ બંધ નથી થઈ ગયું. The reactance line K is at an angle of 90 degree, right, to R axis. So that is known as characteristic angle, and that is a design feature, right? Theta can be different, and then the characteristic cannot be called a reactance characteristic. It will be an ohm characteristic. It will not be reactance. But ohm we'll see afterwards. We are seeing reactance first because reactance has more applications than the ohm characteristic. Therefore, we'll be seeing that first. So, amplitude comparator reactance relay 2Ki minus V is the operating. V is the restraining quantity, right? And the angle, characteristic angle is 90 degree. Phase comparator Ki minus V and Ki, the characteristic angle is 90 degree, right? So this makes the reactance relay. So this is the reactance characteristic which we have seen, right? In this reactance relay, if we want to see the different conditions, say we see the operate condition in amplitude comparator. Amplitude comparator compares 2Ki minus V and V. So V is below the characteristic. Ki is Ki. Ki is the set impedance, or it is set. So 2Ki you can see, double the Ki, 2Ki. So remnant is 2Ki minus V. If you loaf triangle. V is there, 2K is there. So third side is 2K minus V. Direction is shown, but we are not interested in direction because amplitude comparator relay does not rather see the direction. It sees the uh, magnitude only. Magnitude to 2K minus V is more than V. You can see it is more than V. And therefore, relay will operate and relay must operate. 2K minus V and V are equal. V is just on threshold. Right? It is on characteristic. The relay is under threshold condition, right? And if V is out of Ki, that horizontal line, reactance characteristic, then 2Ki minus V is less than V. V becomes more and relay blocks. Relay does not operate. Right? So this is how the reactance relay acts. So where you need the reactance relay, where the application calls for reactance relay, you have to feed 2K minus V and V. Now, obviously, you would think that how to feed these quantities. Ki is available from CT secondary. V is available, that is known. But to sum total them, Ki plus V or Ki minus V, not at all difficult. Operational amplifier can be used as a summator and subtractor. Right? So Ki plus V and Ki minus V can be done. 2K minus V also can be done because Ki is to be multiplied by 2 or amplified by 2 if I want to talk in static terms, in electronics terms. And 2Ki minus V means subtractor, once again use an op-amp. So all these quantities can be realized, and once having realized, you can feed them. Right? When I'm talking about level detector, it's an op-amp which can be used as a level detector. 2K minus V and V. Op-amp, operation amplifier, is a level detector. And if the output is there, I can feed it to the output circuit and make the relay to operate, make the breaker to trip. Right? This is possible. So, if you see phase comparator, then what you have to feed? Ki minus V and Ki. I'm seeing the operate condition. V is below the characteristic. So Ki, V, and third line is Ki minus V, triangle. So direction Ki plus Ki minus V is V. Try it. Write down in your notebook if you have got the notebook open with you. So I'm speaking slowly. Ki plus Ki minus V. I'm sorry. I'm speaking the other way around. V plus Ki minus V. I should speak. V plus Ki minus V. So write down once again. V plus Ki minus V. So VV gone, Ki is remnant, therefore it's equal to Ki. So that is true. My triangle is complete. Vectorially, the statement V plus Ki minus V is equal to Ki is true. So I am comparing the angle between Ki and Ki minus V. So for comparing the angle, I will have to extend vector Ki. I have extended the vector Ki. I have to extend the vector Ki minus V. I have extended both of them. The angle between them alpha, you can see that it is less than 90 degree. Therefore, relay operates. Therefore, relay operates. Because the point is below the characteristic. If point is on the characteristic, then Ki minus V, extended Ki minus V, and extended Ki vector, you can see the angle is 90 degree. Therefore, relay is under threshold condition, right? And if you take the point out V, then extended Ki minus V and V, extended Ki, the angle is more than 90 degree alpha. Therefore, the relay blocks, and it must block because in amplitude comparator also it is blocked. In phase comparator also it is blocking. So amplitude comparator, duality between amplitude comparator and phase comparator exists. Amplitude comparator and phase comparators are dual. I mean, from one, you can build the another. Just a question of sum and summation of summation and subtraction of two quantities that you feed, right? So it is very easy to do this, right? So impedance relay, reactance relay, right? We have seen the impedance relay and the reactance relay, 2 out of 4. Now, Moore relay and Ohm relay, to others we have to see, but I think that we will be seeing in the next tutorial class, because I do not want to extend the length of any tutorial class beyond 30, 35, 40 minutes, usually. So this was what I was telling uh, in the earlier class, that this Swami Anubhavananji has talked about this very good important sentence. Being nobody is unbecoming somebody. Nobody is happy. So what you have to become? If you want to become nobody is happy, means if you become somebody, if you become father, if you become son, if you become owner of the factory, if you become somebody, you should become nobody. आप कुछ है ही नहीं, आपका कुछ अस्तित्व ही नहीं जगत में. देखो आपका क्या अस्तित्व है. What is your existence? Where do you exist? You think where you are sitting. Where you are sitting is in your room or on the road somewhere. That road is in Ahmedabad. Ahmedabad is very big. Ahmedabad is in Gujarat. Gujarat is in India. India is in world. World is in our solar galaxy. And our solar galaxy is part of thousands of other galaxies. And the complete world, जिसको विश्व बोलते हैं, जिसका आधार एक ही है, only one, खुदा बोलो, भगवान बोलो, जो कुछ भी बोलो, an energy, right? Near that energy, you are nobody. So if you want to become nobody, unbecome somebody, somebody ने मत हो. Don't feel अहम मत लाओ कि मैं तो कुछ हूं, आप कुछ नहीं हो. You are nobody. Don't bring ego. Remove ego. You are nobody. If you feel that you are somebody, then it is wrong. Nobody is happy. If you become nobody, you are happy. If you become somebody, you are unhappy. Beautiful sentence. See, nobody is happy, everybody knows. But that nobody into inverted commas is happy is not known to anybody. We know that nobody is happy. वो तो भगवान बुद्ध ने वही कहा. Bhagavan Buddha told that only, that nobody in the world is happy. Then how can you become happy? What is the key to become happy? He found out the key to become happy. Trishna is the key to unhappiness. Desire. आपके मन में कोई ना कोई desire है, तो you are unhappy. Don't keep desire. So, is it possible to have desirelessness? A, a, a rather possibility, or is it possible to become desireless? Buddha told that yes, it is possible. इच्छा का न होना वो संभव है. It is possible to become not to have desire. It's not impossible, right? And that kind of uh, uh, that kind of uh, paristhiti, that kind of sthiti, that kind of circumstances can be brought. So that is what he told. So all saints are saying the same thing. but you have to understand them. Nobody is unbecoming somebody, nobody is happy, and somebody is unhappy. So with that, my friends, I end my talk. Remembering adapt me. Every time I will keep on telling that remember adapt me and talk about adapt me to more and more people. Spread the message. Let more and more people know about adapt me, because we are going to talk about all protections and we are going to learn the complete subject of protection within the big long time up to 80 hours. Probably using experiments and using some numericals, right? But the numericals for practice are not possible, right? Numericals for practice are not possible. Asking questions for examining you, for assessing you is not possible. So if you want to be assessed, if you want to be examined, if you want to do more practice, then you will have to subscribe for module 4, which will shortly be uh, launched. So when it is launched, please subscribe that module and learn distance protection fully. Otherwise, this is there. This free of cost education is there. So thank you, friends, and good day.